let's start by looking at timelines. How can a project manager see if the project is running on time? Well, they should constantly observe the progress against the plan. After all, we didn't build the project plan, the Gantt chart, and the milestone table for decoration. They are super useful tools to measure actual progress with. Here is a small slice of our Gantt chart, and let's have a look at the status of these activities. We can see that the first one has been completed, as has the second and third. The fourth is in progress. We can see we're halfway through. However, the planning documents do not tell us if the actual progress is going at the rate fast enough to complete this on time. So, if a stakeholder asks if this task is on track, well, we don't really know. Yet. But once we learn about what PMI refer to as the schedule variance, that will change. Then we will be able to confidently answer any questions the stakeholder may have about the progress of a task. So, what is the formula for calculating the schedule variance? First, we need to know the planned value. This is the amount of work we plan to have been completed up to this point. For example, for the task Build Walls, there are 4 main walls to be built, meaning 1 wall every week. So at the halfway point, the planned value would be 2 walls complete and work on the third to start. Then we need to work out the earned value, which is the value of work completed to the present moment. In other words, the actual. So, as a forward-thinking project manager, you ask your chief engineer to complete reports each day on the progress of the construction. For the sake of simplicity, let's assume the main work is building 4 load-bearing walls. You have a target to create a wall every 2 weeks, 10 working days. You may see something like this. Cool. We can see wall 1 was completed on time, while wall 2 is at 80% completion. That makes our earned value 1.8 walls. So now, the formula to see if we're on track. The schedule variance is 1.8 minus 2, which equals negative 0.2. That's right, we're behind schedule, and if we don't catch up, this task will be delayed. But by how much exactly? Let's work out the pace of the work and how significant the delay will be using another tool from PMI, the Schedule Performance Index. The Schedule Performance Index is easy to use. We consider the same numbers as before, but this time divide, like this. If the Schedule Performance Index is lower than 1.0, it means there will be a delay. And if it's more than 1, then we're ahead of schedule. In our case, 1.8 divided by 2 equals 0.9, meaning if the team continue at the same rate, they will have completed 90% of the walls by the deadline. Therefore, we will need 10% more time. So, we work out 10% of the 20 working days in 4 weeks, being 2 additional working days needed to complete the task. Can you appreciate how useful this information is? Instead of reaching the deadline and seeing only 90% of the work completed and then relying on the buffer to do the rest, you have given yourself and the project team plenty of time to react. Either you find a solution to quicken the pace, maybe hire more staff or motivate the team, or at the very least, you can prepare the project for a delay by pushing other tasks back. But that's obviously not ideal. Next, we're going to look at controlling costs. Thanks for watching.